So guys, today's our topic is next layer of OSI, that is called transport layer. Okay. Transport layer is called layer number guys 4.
4.
Okay. Transport layer, that is called layer number 4 according to OSI model. Fine. First thing, this layer is very important, or you can say this layer is very crucial layer. Why? Because this layer is responsible to manage end-to-end communication. Understand everyone? Again, I am telling this layer is very important because this layer is responsible to manage end-to-end communication. Getting my point, everyone? What do you mean by here end-to-end communication? Try to understand. For example, if there is a switch, and through this switch, if you connect one PC, that is PC number 2, and with the same switch, you connect one more PC, PC number 1, right? If you are sending any data to this PC, or if you want to make communication possible between switch PC number 1 and PC number 2, getting my point? So before send anything between PC number 1 to PC number 2, both device will establish the TCP connection. Which connection guys? TCP connection. Getting my point? Guys, tell me one thing. For example, if this is me, I'm living here, for example, the flat number 909. Fine. If this is Kapil is living, for example, flat number 910 on the same floor. On the same floor. So if I am telling you the flat number, it means me and Kapil both are neighbor. Yes or no? Agree? Tell me guys. Right na? Because my flat number is 909 and Kapil flat number is 910. It means definitely both are neighbor. Exactly, everyone. Tell me guys. Right?
Yes, sir.
But for example, I and Kapil both are neighbor. But it doesn't mean I will share each and everything with Kapil. Yes or no? Do you guys agree? Tell me guys. Yes or no? Right na? For example, if anyone is living near me, or if anyone is just neighbor, it doesn't mean I will share everything with my neighbor. Everything means, for example, if I cook anything today, for example, I cook a very special thing today. I'm not going to share these things with Kapil until or unless me and Kapil will become the good friend. Yes or no? Right now, everyone. Before sharing anything with each other, or before sharing anything with my neighbor, first of all, we must need to become guys good friend. Yes or no? Right now, if I trust Kapil, then after I can share anything with Kapil. Getting my point, everyone? Do you guys agree? Tell me
Yes,
guys.
sir.
Yes or no? Yes, that is the basic thing. In the same way, there is PC number 1 and PC number 2. PC number 1 and PC number 2 will share anything over the network, or PC number 1 and PC number 2 will share anything between each other. Then first of all, PC 1 and PC number 2 will establish a TCP connection. And that is, you can understand like that is something bond. Fine. Once PC1 and PC2 will share the TCP connection or establish the TCP connection, then after both devices will share anything over the network, there is no problem. Getting my point, everyone? Understand? I hope you guys understand something about the TCP. Clear? So TCP means guys, TCP means just a bond. Fine. Na? For example, if Kapil is living near me or near my flat, it doesn't mean I am the good friend and I have the good bond with Kapil. No. First of all, we need to establish the good bond. Once I will establish the good bond with Kapil, then after we can share anything, right? In the same way in the network, guys. Same thing happen in the network. First of all, if there are two devices, first of all, both devices will establish the good bond with each other. And this is possible because of TCP. Fine. I hope everyone understand what do you mean by TCP. Clear? Understand? So guys, transport layer is called end-to-end communication layer. Why? Because transport layer manages the end-to-end communication. Getting my point? Understand everyone? Are tell me guys, yes or no? Right? Now, after this, you need to understand transport layer provide some functionality, or you can say transport layer has some feature. What are the feature you guys will get at transport layer? First feature transport layer have, transport layer provide segmentation. Segmentation and sequencing. This is the first feature transport layer provide. What is segmentation and sequencing? What do you mean by segmentation and sequencing? Try to understand with this example. For example, this is PC number 1 and this is PC number 2. Both PCs are connected like this. Fine. For example, PC number 1 is sending any data. And the size of data is, for example, 2000 KB. And this PC is sending the complete data at a one time. And for example, anyhow, this link has some disruption. What will happen? Your data will drop. Yes or no? Everyone, tell me guys. Yes, na? Your data will drop. It means this PC number 2 is not able to receive your complete data. Exactly. Everyone, tell me guys. Right, na? So that is the first problem here. What is the problem? PC number 1 is sending the complete data in a one go. And if anything will happen over the network, for example, any types of congestion or anything, your complete data will drop. Fine. Second thing, if you are sending the complete packet at the same time, it means you are utilizing maximum bandwidth over the link at that time. Yes or no? Everyone agree? Are tell me guys, yes, na? So that is the unusual behavior of link. For example, if on this link you are sharing 10 KB, 15 KB, 20 KB, 50 KB data like this, it means that is the normal behavior of the link. But suddenly if you are sending the 2000 KB of the data over the link, that is the unusual behavior because your link is not expecting too much data at the same time, but you are sending. So that's the reason that is the unusual behavior of link. Getting my point, everyone? Anyone who do not understand, is this clear? Tell me. Right? Now, what is the solution? Solution is segmentation. So what layer number 4 will do? Layer number 4 is telling whenever device will send any data towards this destination, first of all, we will divide that data into small parts. Fine. Before sending over the network. Again, I am telling what layer number 4 is telling. Layer number 4 is telling to PC number 1, hey bro, how many data you have? Then PC number 1 will tell, hey, I have 2000 KB data and I want to share this data with PC number 2. Now layer number 4 will tell, okay, I understand. Now we need to perform the segmentation. Then PC number 1 will tell, oh, what is segmentation? What is this? I don't know. Then layer number 4 will tell, you have 2000 KB data. and I am not able to allow you to share the complete data at the same time over this link because it will create lots of problem. So PC number 1 will tell you are the king, do whatever you want. Then layer number 4 will divide this data into small parts. Small parts. Understand everyone? So for example, PC number 1 did 500 KB, 500 KB, 500 KB, 500 KB like this. So just tell me one thing. How many segments you get? How many parts your data divided? 1, 2, 3, 4. Agree everyone? Yes or no? Right? Before we have 2000 KB data, but now I have total 4 parts and each part size is 500 KB and every part is called segment. What is called, guys? That is called segment. Is this clear to all of you? Everyone? Are you tell me, guys? Clear na? So that is called segment. Fine. Understand? So now PC number 1 will share these segment over this network. It means PC number 1 will tell first segment 500 KB, again second segment, again third segment, again fourth segment like this. And for example, if any congestion will happen over this link, maybe one segment will drop, but at least 2-3 segment PC number 2 will receive. Getting my point, everyone? For example, if any types of congestion or any types of flap will happen over this link, but it doesn't mean your complete data will drop. No, maybe 1 or 2 segment will drop, but at least PC number 2 will receive some segment. But before, what was the problem? If any types of flap or segment congestion happening over this link, your complete 2000 KB data was dropping. Agree, everyone? Anyone here who do not understand the segmentation? Is this clear to all of you? Tell me. Fine. Tell me, guys, first. So that is called segmentation. Are you guys able to unmute yourself?
Yes, sir.
Do you guys understand segmentation? What do you mean by segmentation? Tell me. Guys, yes or no? Can't unmute. Why, bro? Now try.
Yeah, now okay.
Okay. So I hope everyone understand what do you mean by segmentation. Fine. Now sequencing. For example, everyone please understand like this. I am giving you one example. Yes, a smaller one. Exactly. For example, this is my PC. This is my wife's PC. I am sharing one thing. I love you too to my wife. And the size of my data is 2000 KB. According to the segmentation, what PC number 1 will do, guys? It will divide my data into small part, right? That is called segmentation. Fine. So for example, this is the segment 1, segment 2, segment 3, and segment 4. So how many segment we have, guys? Segment 1, segment 2, segment 3, and segment 4. For example, segment 1 size is 500 KB, 500 KB, 500 KB, and 500 KB. That's all, everyone. Is this clear? Tell me, guys. Agree? Now, PC number 1 starts sending this segment towards the PC number 2. It doesn't mean PC number 2 will receive every segment in the sequential order. That is not necessary. It is possible maybe PC number 2 will receive the segment number 4 first. And in segment number 4, what is this? 2. This is possible. After segment number 4, PC number 2 will receive the segment number 2, and that is here. For example, then segment 1 and then segment 3, like this. Getting my point? Everyone, do you guys understand what I am trying to say? That is possible. But tell me one thing. What PC number 2 receive? First, segment number 4. What is segment number 4? 2. Then segment number 2, what is? Love. Segment number 1, what is segment number 1? I. Segment number 3, what is? You. My wife will beat me. What are you trying to say me? To love I you. What is this? Getting my point? Everyone, do you guys understand what I'm trying to say?
Yes, sir.
Now there is a role of sequencing. Sequencing means PC number 1 will give one sequence number to every segment. What? PC number 1 will assign one sequence number to every segment. Why? Because PC number 1 is telling to PC number 2, hey bro, I am sending the multiple segment with you. And in multiple segment, for every segment, there is a one sequence number. So once you receive all the segment, you can arrange all the segment in the sequential order by the help of sequence number. Getting my point? Everyone understand what I am trying to say? I hope. Clear? Now,
Yes, sir.
for example, what PC number 1 will do? PC number 1 will assign sequence number 01, 02, 03, 04, like this. PC number 2 receive. So when PC number 1 will receive, this is the sequence segment number 1. In this segment, what is the sequence number? 01, 02, 03, 04. Now, what PC number 2 will do? PC number 2 will arrange all the segment into the sequential order. Into the sequential order by checking the sequence number. So PC number 2 will check. Where is my sequence number 1? This one. So it will put this value first. Then it will check. What is the sequence number 2? This one. Then put this. Then check. What is the sequence number 3? This one. Then that is, what is sequence in that is U, right? And then sequence number 4, that is 2. Now tell. Now my wife is able to understand, yes or no? Tell me. Tell me, guys, yes or no? Right?
Yes.
Yes. That is the benefit of segmentation and sequencing. So by the help of segmentation, TCP is telling, please please divide your big data into small parts, then send over the network. Getting my point? And sequencing is telling, please allocate the sequence number with every segment. So when your multiple segment will receive at the receiver end, receiver can easily understand your data, or receiver can easily arrange your data in the sequential order. That is the use of segmentation and sequencing. Fine. I hope you guys understand very well. Clear? Tell me. Understand? So that is the
Yes, sir.
first feature of TCP, segmentation and sequencing. There is one more feature that is called error detection. Error detection. What do you mean by error detection? Error means fault. Yes or no? Right? And detection means just to find. Yes, na? Everyone, tell me. Right? It means this feature help us to check the error in segment. Yes or no? Tell me. When I am reading this line, I am understanding this. What are you guys understanding? Same or different? Tell me, guys.
Same.
Same. So what I'm trying to say, basically, there is a different feature that is called error detection. So error detection is nothing. Error detection is the feature of TCP layer or transport layer. And by the help of error detection, we can find out the error inside the segment. Getting my point, everyone? If there is any types of error inside the segment, then your receiver device will inform to the sender, hey, this is the segment you send me, but in this segment there is a problem. I am discarding this segment. Please send me the new one or the correct one. Getting my point? Again, I am telling. Try to understand. For example, for example, PC number 1 send the packet with PC number 2. For example, segment number 1, segment number 2, segment number 3, and segment number 4. Am I right? Everyone, tell me, right? PC number 2
Yes, sir.
receive segment 1, segment 2, segment 3, and segment number 4. Now PC number 2 find in segment number 3 there is a error or there is a problem, or maybe this segment is corrupted. Now what PC number 2 will do? PC number 2 will raise another packet or another message with PC number 1. Getting my point, everyone? So by the help of that message, PC number 2 is telling to PC number 1, hey, I receive your all the segment 1, 2, 3, 4, but in segment number 3 that is correct and there is an error. So I am sending you the request. That is called, guys, retransmission request. What is retransmission request? Retransmission request means PC number 2 is telling to PC number 1, please send me sequence number 3 again. Getting my point, everyone? Understand? That is called error and detection. So please understand, this is the first feature of transport layer. Second feature is this one, or you can remember the third feature, that is called retransmission. Retransmission is same. When any packet or any segment will corrupted, or receiver device will find the error, receiver device will send the request to the sender, please send me your correct packet or correct segment with sequence number 003. Getting my point? Even when PC number 2 will send the request transmission, PC number 2 include the sequence number also. Why? If PC number 2 do not include the sequence number, how PC number 1 will understand which packet is corrupted? Getting my point, everyone? Clear? So
Yes,
when
sir.
PC number 1 will receive this request transmission, PC number 1 will find in this request transmission sequence number is 003. It means PC number 2 is talking about segment number 3. Fine. So again, PC number 1 will send the segment number 3 only with PC number 2. That process is called retransmission. That process is called retransmission. Is this clear to all of you? Everyone, tell me, guys.
Yes, sir.
So at transport layer, how many things we got, guys? We learned there are how many feature? 3 feature. First one, segmentation and sequencing, error detection, right? And retransmission. Clear? Are you tell me? Understand? Are you tell me, guys? Yes or no?
Yes, yes, sir.
There is the one more feature at the layer number 4 or transport layer, that is called flow control. Flow control. Tell me one thing. I don't know who is this. Are you guys thinking it looks like you? Cool. Looks handsome. In
Yeah,
class
I
2,
know the
I think
person.
I was
I can't
drawing these
mention
type
his
of.
name here.
Sorry. Okay. Cool. For example, uh, this is the man, and he is the married man. And after marry, he go his sasural. I don't know what is the English meaning of sasural. He go sasural. You know, in when the married guy go to his wife home, or so there they get special what can I say, special treatment, right? Everyone.
Yes.
For example, there are many people come with rasagulla or sweets and inserting in its mouth. Now tell me, this is the poor guy. This guy has capacity to eat the sweet at the same time. Yes or no? Right, na? That is the capacity, na? For example, if I can eat one or two sweets at the same time, but if you are giving me five or six sweets in my mouth at the same time, what will happen? I will vomit. Yes or no? Or otherwise, I will discard. Tell me.
Yeah.
Right, na? Guys, everyone, tell me. I am just giving you the practical thing. So I am just giving you the normal example. So maybe you guys will relate with this. Understand? Tell me.
Yes.
Clear, na? In the same way, for example, this is the router. This is the router number 2 or any device. For example, that is called, guys, interface. Agree? That is called interface. And basically, whenever this router will send anything, and whenever this router will send anything, when this router will send to the router number 2, where router number 2 will receive your packet? Here on this interface. Agree? Tell me. Right now. And when router number 2 will share the data with router number 1, where router number 1 will receive your data? At interface? Yes or no? Tell me, agree,
Yes.
na?
Yeah,
Everyone
yes, sir.
agree? For example, if there is a PC and PC number 2, so whenever PC number 1 will send any data, PC number 2 receive your data where? At this point. Yes or no? Similarly, this PC will receive the data at this point. Yes or no? That is called interface. Exactly. Tell me, guys. Right
Yes.
now? Okay. So no matter which type of device you are using, either you are using router, switches, PC, every device will receive your first point data at its interface. Is this clear to all of you? Everyone. Fine. Now tell me one thing. If router number 1 is sending the data to router number 2 and router number 2 receive the data at this point, that is called interface. Can you guys think one thing? Definitely there will be any memory where router number 2 store your data, whatever you are sending. Agree? Are you guys thinking? Yes or no? Again, I am telling. भाई अगर राउटर नंबर 1 कोई डेटा राउटर नंबर 2 को सेंड कर रहा है तो डेफिनेटली राउटर नंबर 2 के इस इंटरफेस पे कोई ना कोई तो मेमोरी होगा जहां पे राउटर नंबर 2 उस डेटा को स्टोर करेगा. यस और नो? एग्री
Yes,
एवरीवन?
sir.
टेल मी.
Yes, sir.
Guys, again I am
Yes,
telling,
sir.
when router number 1 is sending any data with router number 2, definitely router number 2 store that data at its interface. No?
Yes.
Guys, agree? Okay.
Interface memories.
Exactly. Yes, exactly. Basically, guys, router has memory on its interface. For example, I am giving you one more example. For example, router number 1 send data number 1. Again, router number 1 send data number 2, data number 3. At the same time, router number 2 receive data 1, data 2, data 3 at the same interface. Yes or no? Agree?
Yep.
Tell me. Agree? Now,
Yeah.
first of all, router number 2 will process the data one by one. Agree na everyone? Yes, that is the basic thing. Router number 2 will process these data one by one. Fine. So when this data reach on router number 2 on this interface, first of all, router number 2 process data number 1, and rest data 2 and data 3 will store here, and that is called interface buffer memory. I explain the interface buffer memory in a very easy way. I hope everyone understand. Clear? Everyone. Interface buffer memory. And basically interface buffer memory is the memory that is present on the interface of your device, where devices store your data for very short interval of time. Getting my point? Until or unless it processes the data. And router device will process the data one by one. For example, when data number 1 will process, router number 2 will pick the data number 2, data number 2 will process. Getting my point? Then data number 3 will process like this. Fine. Now try to understand what do you mean by flow control. Flow control means, for example, router number 1 know the size of this interface is 1500 byte. How much, guys? 1500 byte. And router number 1 is sending the data to router number 2 and continuously sending. And for example, complete 1500 byte memory is full. It means if complete 1500 bytes memory full, it means now router number 2 has no capacity to accept more data. Yes or no? Tell me, guys. Agree,
Yes.
huh? Yes. And what if router number 1 is still sending the packet? What will happen? Those packet will, guys, drop. Yes or no? Agree, na?
Yes, sir.
Yes. Because router number 2 interface memory is already full. Router number 2 has no capacity to accept more packet right now because router number 2 is processing rest packet. And if your device is continuously sending the packet, that is the problem. Your packet will drop. And that is called flow control. That is called, guys, flow control. So transport layer manage the flow control also. Or you can understand the transport layer manage the rate at which data is sent. Getting my point? To prevent the other device, to prevent, for example, loss of your data. Because, for example, if the receiving device is not able to receive your packet anymore, its interface buffer memory is already full, your packet will drop. To avoid these things, transport layer perform the flow control also. So basically it adjusts the data flow. Getting my point? And it avoid or it prevent the data loss. Fine. That is called, guys, flow control. So I hope everyone understand the flow control. Is this clear to all of you? Tell me, guys.
Yes.
Okay, cool. Now, how transport layer work? How exactly the transport layer work? Fine. Guys, what I told you, there is a transport layer. At transport layer, there are how many types of protocol, guys? If you guys remember, I told you there are two types of protocol at transport layer. First is called TCP, and second one is called UDP. Remember, everyone. Again, I am telling that is the transport layer that is called layer number 4. Fine. At layer number 4, there are two types of protocol. First one is TCP and second one is called UDP. Yes, na? Everyone, tell
Yes.
me. Yes. Now, TCP is different, UDP is different. Okay, what are the difference between TCP and UDP and how TCP and UDP will work? We will discuss these things later. But right now, just understand on transport layer, there are two different protocols that is called TCP and UDP. Now, start with the TCP. What I told you, for example, this is the router number 1. This is the router number 2. Fine. For example, if you assign any IP address 12.1, 12.2, anything. Getting my point? Everyone, yes or no? For example, what I told you, before sharing any data with R2 and R2 before sending any data with R1, first of all, both devices will establish a TCP connection, right? Na everyone? Yes or no? Which connection? TCP connection. Getting my point? Everyone. Again, I just clear you one thing. I told you at transport layer, there are two types of protocol, TCP and UDP. UDP is not going to establish any types of connection with receiver. It means there will be no connection, guys, between R1 and R2 like UDP. No, UDP will not establish any types of connection. Who establish? Only TCP. Understand? So that's the reason we are telling TCP is more secure. Why? Because TCP established the TCP connection, but UDP is not establishing the TCP connection. Are you getting my point, everyone? You guys understand? Yes or no? No? Tell me at least yes or no. Okay. I'm just giving you one example. It will help you. R1, R2. R1, R2. R1 is sending the, for example, I love you. This is called data. Exactly, everyone. Yes or no? Tell me. Right now? Tell me. Array, R1 is sending, for example, this is the text message with R2. That is called data, na, everyone?
Yes, sir.
Okay, cool. Here R1 is sending the I love you, but in the form of voice. And here R1 is typing. Are you understand now? So here this data is called text format, and here this data is called voice format. Yes or no? Agree?
Yes, sir.
Okay. Whenever data will go in the form of text format, it use the TCP. And here it use the UDP. Is this clear? Now tell me one thing. Whenever you will send I love you in the form of text, it means receiver device is fully, there is a guarantee receiver device will receive the complete information. I love you. For example, if I am sending any message via WhatsApp to Subhajit, definitely Subhajit will receive all my text messages at the same time. Yes or no? Right? There will be only two scenarios. Either he will receive or either he will not receive. Getting my point? Tell me, right? Na?
Yes, sir.
Is there any chance, for example, I am writing, how are you? I am sending, how are you to Subhajit. Is there any possibility Subhajit receive how and you? R is missing?
No.
No. Why? Because, for example, I am sending with my phone. Subhajit is going to receive at its phone. It means between my phone and Subhajit's phone, TCP connection will establish. Yes, na? So what is the use of TCP connection? TCP connection will ensure there is perfect connection between my device and Subhajit device, between R1 and R2. And when TCP will give you the green signal, then your device will send the data. And if the TCP connection is telling you no, there is something congestion or there is something wrong over the link, then R1 is not going to share the data with R2. Getting my point? Everyone, I hope you guys understand. Clear? But for example, I am on call with Subhajit. For example, I am telling, how are you, brother? Maybe it is possible he listen only, how are you? And he miss brother word. That is possible? Yes, na? For
Yes, sir.
example, if you are talking over the phone with your friends, with your family, sometimes you are telling, na, your voice is not coming, tell me again.
Mhm.
Yes or
Yes,
no?
sir.
That is the basic thing.
Yes, sir.
Why you are facing these things? Because of the UDP. Because of the UDP. Because
You
if you are using the voice call, if you are using the video call, there is a UDP connection. And UDP connection never establishes the proper connection. Getting my point? Because in case of TCP perform handshake. There are handshake, 3 types of handshake we are going to discuss. But in case of UDP, UDP is not going to establish any types of handshake. Getting my point? That's the reason between R1 and R2, there is no something permanent connection like this. So that's the reason we are facing the drop issues. Clear? Stand? But in case
Yes.
of TCP, we are not facing. I hope now you guys understand in very well where we are using the TCP, where we are using the UDP, and what is the use of TCP and UDP. Is this clear to all of you? Everyone, tell me.
Yes, sir.
Yes, sir.
Now, unmute. Now check.
So, sir, actually TCP UDP, the port is connections. It is seeing in command prompt possible.
Sorry. In TCP
TCP
UDP?
UDP in command prompt seeing that is
No.
possible
No,
where
no,
it
no,
is.
no, no. No, no, no. But on router CLI, I will show you how actually the TCP and UDP connection established. You guys can able to see the established connection. I will show you, no worries. Okay. Now, TCP. What I told you guys, whenever you are using the TCP establish the handshake. TCP perform what guys? Handshake. Right na? Are tell me. Handshake na? Tell me. Right
Yes, sir.
na? For example, if this is me, this is you, first of all, whenever we meet, we will do na handshake. Yes or no? Right na? When we will do the handshake,
Yeah.
when I and you will be comfortable, then I will exchange something about me and you will exchange something about you. Agree? In the same way, guys. In the same way, networking will happen. See, for example, if you are using the TCP, when both device will be in the network, how TCP, the question is how TCP connection will establish. What is the question? How exactly TCP connection establish? So answer is TCP connection will establish because of three-way handshake. What is three-way handshake? What do you mean by three-way handshake? Anyone? Three-way handshake. Any idea? No? See. For example, this is router number 1. This is router number 2. Both are connected like this. 12.1, 12.2. Here we are using the fine. So for example, this is the sender and this is the receiver. I understand everyone. This is the sender and that is the receiver. Fine. So what sender will do? Sender will send one message first to establish the TCP connection with R2. And that is called SYN. SYN means synchronize. What is guys? SYN. SYN means synchronize. Who is sending? Sender is sending. Right? Who receive? R2 will
Yes.
receive. What R2 will do? R2 will give the reply of the SYN. Fine. So what R2 will do? R2 will generate one message and in this message there are two things. SYN plus
Act.
ACK. What do you mean by this? It means, first of all, R2 is sending its own SYN. On means R2 SYN. Understand? And who is sending this SYN? This is the R1 SYN.
And
Yes, na? So R2 is sending its own SYN. And what is this? This is the acknowledgement. This is the acknowledgement of R1 SYN. This is the R1 SYN acknowledgement. Understand, everyone? Are tell me. Clear? Understand?
yeah, yes,
Yes,
sir.
sir. R1 send the messages and R1 receive that one plus
R1
acknowledge.
is telling to R2, hey bro, I want to establish a connection with R2. R2 receive it. Now R2 is telling to R1, hey bro, I want to establish the connection with you as well. So I am sending my hello also. Apart from this, R2 is telling to R1, hi bro, you send me hello and I receive your hello very successfully. Is this clear? Tell me.
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay. Now, finally, R1 will send one more message that is called acknowledgement. Now R1 is telling, thank you very much, bro. You for your interest to establish a connection with me. I want to tell you your SYN message I received very successfully. So that's the reason I am giving you the acknowledgement of your SYN. Anyone here who do not understand the three-way handshake? Anyone? I hope now everyone understand three-way handshake, how R1 and R2 establish a three-way handshake, or how R1 R2 perform the three-way handshake. Clear? Everyone? It means now R1 and R2 both are already agree over the SYN and acknowledgement. It means both devices are now ready to exchange the data. Tell me, yes or no? Tell me, guys.
Yes, sir.
Clear? Oof. Okay. So that is called, guys, three-way handshake. That is called three-way handshake. And who perform three-way handshake? TCP. Fine. And there is an interview question. What if interviewer will ask you, what do you mean by three-way handshake? How can you answer? You can say, sir, three-way handshake is the process, and this process is used during the TCP connection establishment, right? And by the help of this three-way handshake, sender device and receiver device will establish a proper connection before sending any data over the network. Right? Everyone, tell me. Guys.
Yes, sir.
Okay. Now, if I will be your interviewer, I will ask you, yes, you are correct. But tell me, what do you mean by four-way handshake? Is there any four-way also? Answer is yes. In TCP, there are two types of connection, that is called three-way and four-way. Now, what do you mean by four-way handshake? See, R1, R2. Fine. In four-way handshake, what will happen? See very carefully. For example, this device. First of all, understand one thing. Four-way handshake. Four-way handshake generally we use to terminate a session. What is terminate a session? So there are two things. Either you want to establish a session or either you want to terminate a session. If you want to establish a session, which type of handshake you guys will perform? Three-way handshake. And if you want to terminate a session, which type of handshake you will perform? Four-way handshake. Clear? Everyone. Understand? Now
Yeah.
R1 wants to drop a session with R2. So R1 send first message that is called fin. Fin means finish. R1 is telling to R2, hey bro, that's enough. Now I want to finish the session with you. R2 receive this fin. R2 immediately send one message that is called acknowledgement. R2 send, yes, I receive your fin and I am acknowledging your fin. And by the help of this acknowledgement message, R2 is telling to R1, I receive your fin message successfully. Getting my point? Everyone, tell me. Understand?
Yep.
Now, R2 will tell, you want to terminate a session with me? R2 will tell, you want to terminate a session with me. Okay, now we are not friend. Okay, do. If you want, I also want. R2 immediately send one more message that is called, R2 will send a fin message with R1 also. Now R1 received the fin from R2. R1 send again acknowledgement. So how many messages? 1, 2, 3, 4. Understand, guys, everyone. So what is the use of four-way handshake? By the help of four-way handshake, device terminate a session, and by the help of three-way handshake, device establish a session. Is this clear to all of you? Everyone. I hope now there should be no confusion. Clear? Understand? Okay. Now that is all about the TCP. Now
That
about the
fin what finish?
fin means finish. Yes. Now UDP. Do you guys know something about the UDP? Okay. Before understand the TCP or UDP, understand one thing. TCP use protocol number that is called 6 and UDP use the protocol number 17. That is the difference. You have to remember this. Okay. Now focus on UDP. Please understand one line about the UDP. First of all, TCP is a connection oriented protocol and UDP is
Connectionless protocol.
connectionless protocol. Why I am telling this? Why I am telling this? Because guys, if you use TCP, I told you, na, TCP perform three-way handshake. Yes or no?
Yes, sir.
If you want to drop a TCP connection, TCP perform how many handshake? Four-way handshake. Yes? Tell me. Right? Huh? It means if you are using the TCP, your device is orienting the connection. Yes, na everyone? Yes or no? Right? But if you are using the UDP, there is no any three-way, four-way types of connection. Getting my point, everyone? So that's the reason we are telling TCP is the connection oriented, because before sending anything, TCP first of all exchange some messages like send acknowledgement like this. Getting my point? But in case of UDP, you guys will not see any types of messages. Getting my point? So that's the reason. This is the difference. TCP is called connection oriented and UDP is called connectionless. Fine. Now, second thing. Who is faster? TCP or UDP?
UDP.
UDP will be faster. Why? Because guys, think na, TCP first of all establishing a connection like sending the messages, but UDP is not doing like this. So that's the reason UDP is fast and UDP is slow. Now again I ask you, tell me who is more reliable? TCP is the reliable. We can trust more on TCP compared to UDP, because I believe if you are using the TCP, it means you already exchange the messages and connection is already established. Then after you are exchanging the data. But in case of UDP, there is no such type of messages exchange. Right now? So that's the reason if you ask, sir, on which protocol you have a more trust, then I will tell TCP. And TCP is the reliable. Reliable means what? if I am telling here reliable, what do you mean by reliable? Reliable means for every messages you guys will get the acknowledgement. For example, if you are doing any payment to me, I am telling, na, please send you the screenshot. Yes or no? And I am giving you, yes, I received. Agree? Why I am telling you I received? Because you got the acknowledgement. Yes, whatever I am sending, the receiver received this successfully. Tell me yes or no. Agree, na? But in case of UDP, you guys not get the acknowledgement. You guys not get the acknowledgement. For example, if I am talking to you, if I am sending, I am talking with you over the phone, or if I am talking you over the Zoom or anything, I will not get the acknowledgement. Whatever I am trying to say, you will receive or not. But in case of TCP, I will get the acknowledgement from the receiver side. Whatever I am trying to send, you receive successfully or not. That is the meaning of reliable. Is this clear, everyone? So what is the conclusion? Conclusion is TCP provide us guarantee of delivery. Yes or no? UDP don't. Yes or no? Agree with me, everyone? Right, huh?
Yes, sir.
Yes. TCP provides us guarantee of delivery because whatever you are sending on TCP, you guys will get the acknowledgement for this. But in case of UDP, you are not getting any acknowledgement. So that's the reason I am telling in UDP, UDP do not provide you guarantee it's delivered or not. But in case of TCP, it provide you. Is this clear to all of you? Everyone, tell me. Tell me,
Yes, sir.
guys.
Yes,
Yes
sir.
or no? Now, did you guys ever see the TCP packet? TCP packet means, guys, I am talking about the TCP header. If you guys remember, I think in previous class I told you, for example, if you are searching anything here on the browser, and this is for example Chrome, and for example here I write facebook.com, my packet will generate at layer number 7. Sorry, right? Packet move layer number 6, layer number 5, then move at layer number 4. Yes or no? Right, na?
Yes.
At layer number 4, what will happen? At layer number 4, for example, layer number 4 receive the data from layer number 5. Now layer number 4 will check this data belongs and this data use TCP or UDP. Right now, everyone? I think in previous class I've already explained these things, right? For example, layer number 4 find, yes, for example, this is the HTTP data and HTTP is my child and HTTP loves either father, either mother, that is called UDP. And I told you HTTP loves father, that is called TCP. Right now, everyone agree? Tell me, guys, yes or no? Yes? Okay. So for example, this is the HTTP data and this is the layer number 4. So at layer number 4, what layer number 4 will do? Layer number 4 will add TCP information here. Yes or no? Because HTTP use the TCP. So layer number 4 will add the TCP information with this data. Exactly, yes or no, guys? Tell me. Right,
Yes,
na?
sir.
Yes. And for example, if there is something different, then it will use the UDP. Fine, everyone. But for example, TCP. So TCP use the, sorry, HTTP. HTTP use the TCP. So what is this? TCP data. I am telling you TCP data. TCP data means I am talking about the TCP header. What is, guys? TCP header. Clear? Anyone here who do not understand? Is this clear? So at layer number 4, what will happen? With your data, either TCP header will attach or either UDP header will attach. Getting my point, everyone? And the complete, this data is known as segment. What is segment? Clear? Are you tell me?
Yes, sir.
Understand? Okay, cool. So what I am telling you, at layer number 4, TCP header will attach. Now, just focus on TCP header. I am telling you something about the TCP header, not in the detail way, but yes, in the giving you the overview of TCP header. In TCP header, generally you guys will get multiple things. For example, you guys will get source port number, destination port number, and I hope everyone is now aware about the port number, right? Are you tell me? Now, sequence number, now acknowledgement number, now data offset, now reserved, now flag, now checksum, urgent pointer, options, data. So guys, basically these are the content you guys will get in the TCP header. These are the content you guys will get in the TCP header. Getting my point, everyone? Understand? Again, I am telling these are the content you guys will get in the TCP header. Clear, everyone? Now, what do you mean by port number? Anyone here who can tell me what is the use of port number?
To identify the destination and the source to reach the packets.
Yeah. Yes, in yesterday class, I already explained you guys that application layer, you are using different services. Yes or no?
Yes, sir.
How your layer number 4 will identify which services you are using at application layer? Because of port number.
Number.
Agree, na? Everyone. That is called port number. For example, I am writing on my browser at facebook.com. So either I will use the HTTP or either I will use the HTTPS. Right, na? Tell me, guys.
HTTP.
Right? For example, if whatever you are searching here, whatever you are searching on your browser, that is the source. And for example, whatever you are searching, for example, you are searching the facebook.com or something else. It means you are, whatever you are searching, that is called destination, right? Again, I am telling there are two things. Whatever you are using, that is the source. Whatever you are searching, that is the destination. Getting my point? Everyone, tell me. Agree? Right, na? So, what is port number? Port number is nothing. Port number is very critical in the computer networking, guys. And this allows you to identify which type of application or services you guys are using at application layer. And that is because of port number. Fine. And for your information, I just want to tell you the port number range is 0 to 65,535. This is the range of port number. Getting my point? Understand? Tell me. Right, na? So these port number, either these port number will use the TCP or UDP at layer number 4. Clear, na? For example, HTTP. HTTP use the port number 80. HTTPS. HTTPS use the port number 443. FTP. FTP use the port number 21. Right, na everyone? Yes or no? I told you these things yesterday class. Tell me, guys. Yes or no? Agree, na?
Yes, sir.
Yes, sir. Yes. Yes.
So there are basically, guys, two types of port: source port or destination port. Source port or destination port. Now, what do you mean by source port or destination port? How can you define? Basically, source port, this port, source port is the number of sender side. That is the sender side port number. And generally, you guys will get this port here. You guys will get the random value. Which value, guys? Random value. Getting my point? It means this value basically assigned randomly. Fine. And what do you mean by destination port? And here you guys will get the well-known port number. Well-known port number. For example, HTTP. HTTP is the well-known port number because we know what is the port number for HTTP. 80. What is the port number of HTTPS? 443. So again, I want to clear you in on source port number. Generally, you guys will get the random value as a source port. And in destination, we get the well-known value. For example, HTTP, HTTPS like this. Is this clear to all of you? Everyone? Are you tell me? Understand na?
Yes, sir.
For example, you guys will get 21 at the destination port. That is the FTP, 22, SSS, 25, SMTP, 53, DNS, 80, HTTP, 443, HTTPS, like this. Fine. So if anyone asks you, sir, what is the well-known port and what is there any range? Yes, guys, 0 to 1023. This is the range of port number and that range is called well-known. That is called well-known range because from 0 to 1023, these port number is already reserved for any services. Getting my point? Everyone. Is this clear to everyone? Tell me. Right?
Yes, sir.
And there is, if I am not wrong, you guys can check on the Google, I think 1024249151. This is the registered port. I think registered by the INA. Okay, everyone. Clear na? That is registered by the INA because INA specify these port, I think, to a specific application. For example, MySQL, Microsoft SQL Server, right na? For example, 3306. That is the reserved for the MySQL. And for example, MySQL Server, I think 1433. This port number used by the Microsoft SQL Server. Okay, so this range of port is reserved by the INA for a specific application. Fine. And the rest one is called 49152 to 65,535. That is called random port number or dynamic port number. So that's the reason on source port number, generally you guys will get the port number value from this range. Is this clear to all of you? I hope so. I told you in a very detailed way. Understand, guys? Yes or no? Tell me.
Yes, sir.
Right now. So that is the source port number, guys, and that is the destination port number. Now, I hope everyone is now already aware about the sequence number, right? What is the use of sequence number? TCP just provide the sequence number with every segment so receiver device can easily arrange all the packet in the sequential number. Clear na? Everyone, tell me. So sequence number just ensure that whatever the data you are delivering and receiver device receive that data in the correct order. Nothing else. Fine. And sequence receiver device use this sequence number for the retransmission also. For example, you send the 1, 2, 3, 4, 5 segment with 5 sequence number. For example, sequence number 4 drop. So how receiver device will inform the sender device? I receive the sequence number 4 that is incorrect with the help of sequence number, na? Yes or no? Yes.
Yes, sir.
So that is the use of sequence number. By the help of sequence number, receiver device will arrange all the data in the sequential order as well as inform the sender device for the retransmission. Fine. Acknowledgement number also, right? I hope you guys understand something, right? Now, reserved bit, please understand, reserved bit always be 0. Reserved bit always be 0. And this reserved bit basically is reserved for the future users only. Okay. And there is a flag. Yes, TCP use the some flag also. There are 9 bits of flag. Okay. Now, next one is, guys, checksum. What is the use of checksum? Basically, checksum, TCP use this field, checksum, to find out the error, detect the error in the TCP segment. Fine. What is the use of checksum? To find out the error inside the TCP header. Clear na, everyone? Are tell me, guys, yes or no? Yes, na? What do you mean by urgent pointer? Urgent pointer is nothing, just points to the you can understand like this. By the help of urgent pointer, you can send any packet urgently. Fine. For example, if this is the device and here on this interface, data 1, 2, 3, 4, 4 data is there. And this router is processing the data one by one. And for example, if in this segment, urgent pointer field is on, so it means this router will process this one first. Getting my point? That is the use of urgent pointer field for important data. Clear? Understand? Tell me, guys.
Yeah.
Okay. So that is all about, guys, TCP header. I hope everyone understands the TCP header very well. Clear? Tell me, guys. Understand?